Right. Uh, so what will be the result for that? Minus u1 u2 u1 u2 plus g square t square is equal to 0. So you get gt is root u1 u2 and t is equal to u1 u2 by g. Now I am writing this part here. Time for them to be perpendicular to each other. Which one? The velocity vectors. In a similar way, they can ask when are these displacement position vectors are perpendicular or displacement vectors are perpendicular, and what is the distance of separation between them. So how do you get the distance of separation? What is the time they have given is under root u1 u2 by g, and then this is your x2 y2, this is of course minus x2, and this is x1 y1 coordinate. Remember, both are y because it is half gt square and half gt square, because this is a simultaneous projection. So you should not miss on that point. Therefore, what is the difference means this minus this you get. So x1 minus of minus x2, it is x1 plus x2. Or you are working on this. So this is x1 mod, this is x2 mod. So the distance of separation between them will be, what is x1? u1t, x2 u2t. Therefore, u1 plus u2. What is t? Under root u1 u2 by g. Now I think this should be clear to you. I hope you understood this. My question is, when you project both the bodies simultaneously from the top of a tower horizontally in the opposite direction, I just want to know, when do these velocity vectors become perpendicular to each other? So that is what we are trying to work on. What is the distance of separation? Because it is simultaneous, they are at the same level. Okay, there is no issue. So now we have got that to be equal to x1 plus x2. Okay, now the same thing I can work for s1 and s2. So if it is s1, s2, what do you do? S1 dot S2 must be 0. So what do you get? Look at that. U1t into minus U2t. So then you have t square plus half gt square whole square is equal to 0. Or half gt square is. So t, if I take it, I will get it as, now you see, exactly the time taken is twice that of the previous case. That means first the velocity vectors become perpendicular, doubling after this, the displacement vectors become perpendicular. So that is precisely what you have got. Again, they may ask what is the distance of separation. So you say x1 plus x2 likewise. So there is no issue here. Straightforward, simple, no problem. I'll tell you. For example, if these are not projected opposite to each other, what's going to happen? Let us look at a simple case that U2 is projected perpendicular to U1 likewise. So it is a 3D case, you remember. What is the 3D case? You see, this is U1, I, this is J, this is K. So they may ask what is the distance of separation between these two particles at any time t. What do you do? If this is x-axis, I'll say it has gone x1. x1 is equal to u1t. At the same time, what has this gone? Let this be z for the time being, z. So z, what is that? u2t. So you have u2t, u1t. These two are perpendicular. I can't draw it on the board, but I'm showing it to you. u1t, this is u2t, this is z-axis, this is x-axis, this is your y-axis. Because they have come down to the same level. What is the distance of separation between these two? What do you write? u1 square plus u2 square under root into t, distance of separation. t into root of u1 square plus u2 square. You have got, in the other case, it will be u1 plus u2 into g. Now, under root u1 plus u2 into t at the same time. If it is 90 degrees, did you understand this, what I have said? Now, one I am projecting one into the board. So this has come down like this. I am asking the distance between these two. Okay? Now, if it is opposite, you are getting u1 plus u2. If they are in the same direction, it will be u1 minus u2 or u2 minus u1, whichever is more. So, same direction projection. Then u1 minus u2 into t. So all depends on the angle. That means what is the angle of projection between u1 bar and u2 bar? If it is 0, I am getting u1 minus u2. If it is 180 degrees, I am getting u1 plus u2. So how do you write? If it is any angle theta, now this is u1, u2, angle between them is theta. That means I am virtually getting the third side of that triangle. You got my point? This one and this one. Okay? What is the third side of the triangle? How do you get it? Under root of sum of the squares of these two minus what? 2 into the sides into cos theta. You got the point? If I have a triangle, likewise, say this is A, this is B, this is theta, this is A square plus B square minus 2AB cos theta. That is what you have to memorize every time. So here how do I write? Let that angle be general angle theta, then the distance of separation after time t for u1, u2, remember in the same plane they are projected likewise. So you have t into under root of u1 square plus u2 square. This is the distance, generalized distance of separation between the two. So you have to be very careful in understanding. What I gave you was simplest thing, but this is the most general thing. I hope you have understood. I repeat here, from the top of the tower, one body is projected like this. So after a certain time, this is the velocity, okay? You got it? And after a certain time, this has gone here. So I want to know what is the distance between these 2 points. So at horizontal, that part is u1t, u2t. So it is a triangle with not isosceles, but u1t, u2t, and then angle between them is theta. If they are opposite, you will get u1 plus u2 into t. If they are in the same direction, you will get u1 minus u2 into t. Or u2 minus u1 into t, it doesn't matter. You got the point now? That is how you get the distance of separation between the particles for simultaneous projection. I hope this point is clear. Now, sometimes what happens, I'll tell you. If it is not a simultaneous projection, they may give problems like that. What do I do? First, a body is projected, say with U1. Maybe after some gap, body is projected with U2. Right? Maybe I'll take some 2 seconds later. Okay? Now, this probably will be like this will be like that. Now, if this particle is here, this particle will be there. Now, this is important point you should understand. If I take this time to be t, this will be t plus 2. Now, here I don't want any one of you to get confused. Which one to take t, which one to take plus 2, minus 2. Never get. Always look at which one is more, which one is less. Now you have got this more, so that's what you have to do. If you take t, this is bound to be t minus 2. If you take this t, this is bound to be t plus 2. That's what you have to see. And sometimes they'll ask you in the question, time with respect to whichever he gives, you take that, right? So while writing the equations, what is the distance of separation now? This is the distance of separation. You got the point? This is the distance of separation. Then look. This is x1, this is x2. What is this? If this is y2, this is y1, therefore this is y1 minus y2. What is this distance? Plus this is the distance of separation, remember. Now this is t plus 2. So half g into t plus 2 whole square y1 y2 whole square plus what is x1? x1 you have already written there, u1 into t plus 2 and this is u2 into t whole square. Well, simplification you can do and then get the answer. This is simultaneous projection, but if the particles are projected not simultaneously, then what? Simultaneous we already saw. This is non-simultaneous. One body is projected after the other. That's what we tried to do, and then we got such as the answer. I hope this is clear to you. That's how you have to work out the problems based on this. Now, what kind of models do you come across this? You know, they may say that probably a fighter aircraft cruising at a particular altitude with horizontal velocity u drops a bomb when there is a fixed target on the ground, say at any height h. If it is dropped, will it hit the target? There are several questions in this. If that is the case, after some time, if I see now this body will acquire this position, I am trying to give you this position. This is aircraft. Now you can see the pilot of the aircraft sees that the body falls vertically down. Now this is important for you. Do you understand this point? What do you mean by falling vertically down? For him, it is a straight line. Oh, for the pilot, path is straight line. For a ground-based observer, how does it look like? Let's say for ground-based observer, path is parabola, same as projectile, and it will miss the target obviously because miss the target. By what distance does it miss the target? So what should you do? Time taken is under root 2h by g, right? And the speed is u. So this is the distance by which that body misses the target. That's how you have to give your answers to these questions. I hope this is clear to you. I'm just trying to give one straightforward, simple application. All right? Now, the next part is we have already seen oblique projectile from the top of a tower. We have seen oblique projectile, horizontal projectile on the top of a tower. We also saw oblique symmetric projectile on the ground. Now there are certain general, see, suppose if I take what's one thing from the other projectile, how does it look like? One projectile means you have certain value, right? For example, y1 is equal to whatever it is, u1t minus half dt square, and y2 is equal to u2t minus half dt, simultaneously I'm talking about. And x1 is equal to not u1, this could be v1t, x2 is equal to v2. This is a general way we take projectile equations. You know that. Y is ut minus half dt square, this one. Now, I want to observe. Observe means what? You generally take, how does y1 minus y2 look like? This is u1 minus u2 into t. In a similar way, what is x1 minus x2? v1 minus v2 into t, because half gt square gets cancelled. If I add these two, what am I getting? If I take this as y dash is a constant quantity. So y is proportional to x, therefore it is a straight line. So if you are in one projectile, you are observing another projectile from this projectile. That always appears to be a straight line. Okay? Maybe when relative velocity is discussed, probably you will understand this much better. I don't want to miss on this point here. Therefore, I have given this. Now, next one is collision of two projectiles. Suppose H1, H2, likewise this is U2, U1, this is theta 2, this is theta 1. You see that? I have given all that. I have the same plane. I projected two bodies simultaneously with U1, U2 at angles with horizontal theta 1, theta 2. Got the point? Theta 1, theta 2. Then, when do they collide? That's the first question. Second, do they collide at all? You don't know. Supposing if this body were to go without this, its path could have been like this. In the absence of one body, other body's path I gave. If this were not to be present, this is how. When I draw them simultaneously, they are intersecting. What does this point of intersection mean now? You have to tell me this. What do you mean by this point of intersection? Does it mean that these two particles collide there? I am giving you time so that you will think of it. See, if it were to be an interactive class, maybe I could have made you give these answers. But this is not so. But still, I am trying to make it as realistic as possible. So I'm giving some time for you to think. At least you can put a note on your notebook that yes, this is what I'm thinking. Now, let me give you the answer. Say, for example, these are separated by a horizontal distance d. They are in the same plane. Point of intersection means both the projectiles pass through this point, definitely, but not necessarily simultaneous. I hope you have understood this. I repeat this. When you have a point of intersection, it means both the projectiles pass through that point, maybe one after the other, may not be at the same time. Whether in both the first case or the second case, definitely you will see a point of intersection there. Therefore, point of intersection is not the complete proof for the bodies to collide. They must go there simultaneously. Let me presume that they will meet in time t. They will definitely meet there in time t. Now you see, this is the point of intersection. Okay? Now, from here till here, if you see, this is y2. Agreed? And this one, this is nothing but y1 from this point and above. Okay? So, if this is x1, this is x2, x1 plus x2 must be equal to d. Don't take here any sign conventions. So, x1 plus x2 must be equal to d. And if I take modulus, what is x1? Directly you can write u1 cos theta 1 t plus u2 cos theta 2 t is equal to d. These two equations. In this time, if it reaches, that is not enough. The y coordinate also must be same in the same time. How do you write the y coordinate? Now you see that this point's height is from the ground h2 plus y2. It should be equal to h1 plus y1, because this is same. h1 plus y1 or h2 plus y2, both are same. Or I can write h1 minus h2 is equal to y2 minus y1. But y2 is u2 sin theta 2t minus half gt square minus u1 sin theta 1 t plus half gt square. I hope you got this. Both are in the same direction. Both, I put it both are plus. So you are getting this. What is this equal to? u1, u2 sin theta 2 minus u1 sin theta 1 into t. That's what I am writing here. Got the point? u1 sin theta 1 minus u2 sin theta 2 into t h1 plus h2 minus h1. You may reverse this or reverse there. It doesn't matter to you. If it is 1 minus 2, it should be 2 minus 1 there. Now condition is these two times must be same. So if I divide these two, now for the bodies to collide, this is the condition. This is very important. What is the condition for bodies to collide? These ratios must be valid. In what time it collides and all that, you can clearly find out if the data are given to you. Okay? Now, I'll try to give you in my recap, what are the equations I have derived, some important equations. They will be useful to you for a ready reckoner. Now, first thing is, you see, this is ground to ground, symmetric projectile, u theta. Okay? Now, the time of flight here is 2u sin theta by g. R is equal to u mod b sine of the angle by g. In symmetric case, it is u square sine 2 theta by g. So R you can always write as u cross square by g, and you get R max as mod u mod v by g, and the angle is tan inverse u by v. Never forget this. In this case, R max is theta is pi by 4. That is how you have these relations. I mean, this is well known to you. This is as far as that is concerned. And the same thing, you have tan theta is h by r, or 4h by r, or tan theta by 4 is h by r. So you have h expression, t expression, eta expression, all these things you have. Now, I also gave you t theta, t90 minus theta, h theta, h90 minus theta, and you know how these are related with your r. All those expressions I have tried to give you, and then h by r is greater than or equal to or less than 1, various cases. I'll just try to show you here. This is maximum range. Now, if I do with 15 degrees, but if I go with so likewise, these things are bound to be the same. Now you can see. The ranges are same here. This is the maximum range, right? So this is all pertaining to H and R. And every time these projectiles are given, I want you to learn how to write this in vector notation so that you can work out any problem based on this. Okay? Then you have seen oblique projectile from the top of a tower. Likewise, this is h, this is theta, that is u. What is time of flight? U sin theta by g whole square plus 2h by g plus u sin theta by g. This is what we have written as the Now if it is a projection like this, we would write here minus. And here also you can write your mod R is equal to mod of U cross V by G. And here maximum, what is maximum? R max is equal to mod U mod V by G tan inverse U by V. Now what is V here? Now look at that last expression. So mod V at H is equal to U square sin square theta plus 2GH. Plus U square cos square theta. IU cos theta plus J under root of, oh got it. You remove the root there, it becomes square, and you square it. What do you get? So mod V is equal to under root of U square plus 2GH. That is what you will. It's very important relation. U under root of U square plus 2GH by G. Very important, my dear friends. I am trying to arrive at this in the most simple fashion without getting into any complications whatsoever. And the angle at which you have to project is mod U by under root of U square plus 2GH, which is less than pi by 4. If they ask you whether it is a javelin throw or shot put, what angle should you project such that it achieves maximum range? Never give the answer as 45 degrees, because nobody will lie down on the ground and try to project the body, isn't it? Will you ever do that? The same thing, you take a shot put and then lie down on the road and then try to project it. You will always do it at your shoulder height. So the shoulder height is your pitch. Then automatically it is less than 1, therefore the angle is less than 45 degrees. So this is a very, very crucial thing for you. And in the final thing, I have tried to give you the horizontal projectile, and an application for that also I have given. And then I tried to give several. See, when the projectile can inscribe a triangle or a regular hexagon with only 4 vertices being on the trajectory. And then as far as the fixed target is concerned, what should be the minimum velocity with which you should project, etc. I have given. The minimum velocity, we have derived it, you got an answer, and then for that there is only one angle. But if you choose to go with any other value than the minimum or the critical, then you have 2 angles at which you can hit that. This is without air resistance or any such thing. You understand? So this is how I have tried to give you, my dear friends, as far as projectiles are concerned. And now, as I said, if you have any queries, please post them to me. I will try to address. I have not tried to solve any problem here, because problem solving, I think, is a technique which you should develop on your own, and you have to evolve on your own, so that you must be if you can do that only if you understand the concepts. And I have tried to give as many concepts as possible, if not all. Still, there are quite a few things. Probably this may not be the right time to talk about it, like radius of curvature of a projectile, etc. I'll do that maybe when I go to circular motion, etc. Okay? Now, thank you for your patience. Bye.